Now that we have our full data frame with all the columns that we need, and I think we called it, what did we last call it? Okay, state df full. Notice that sometimes I call these df, but because I work with df so much, I almost assume everything is df, that is data frame. Don't even need to add that to the name, but sometimes we do. It's good to have a clear name, as clear as possible, but of course without having too many words. But always remember that, when you start typing, you can press tab. If you press tab, it should come up. I don't know why it's not coming up here, but to see the columns, we just go like that. We can see all the columns that we had, and we have too many columns. We're not going to use this. Let's clean this up. It's useful when we need to save the data and make it faster processing and also easier to read. So this is a way for us to select all of the columns that we want in a new data frame. This is instead of dropping and deleting, you just select the ones that you want and add it into a new data frame. That's the way I like to do it. So you identify the ones you want to keep, and notice how it works is this is the name of the data frame we have, and then we have 2 square brackets, and then just a list of the names of the columns you want to keep, separated by comma. And then you notice once we can go into a new line, Python is allows us to do this, but make sure you stay within the beginning of the other area here. So this is kind of how it works in Python. The tabbing is very important and also makes it very clear to read, which is actually good. And then I'm loading that into a new clean full data frame, stateful clean, and it looks like this, and you can tell it looks just already much better. All the data are in integers as we need. The numbers are not text. The text are text. There's some extra. This one here I added property taxes. This one looks like it wasn't correct data typed and correct processed. Property tax, if you want to use it, you can. Or there's another one that's interesting, which is income tax. So see if there's a relationship there. Ideally, we would also have everything like either use space or use underscore, and underscore is better because then sometimes when we even need to use quotes, we can just use the name of the column like this, state code. You can just use it like that. But if you don't have, if you have a space, you can't do it like that. You have to do it like this. So property tax was not formatted, so I kind of kept it in this last iteration here, but it's maybe not a good choice because it's not even formatted. Should have formatted first. Of course, you can still format it after this. Make sure you turn this into an integer or something, and then you got to think about what to do with this x. But everything else is properly formatted. Poverty percent, these are percent. Poverty estimate, these are numbers of people in poverty. Total taxes, it's written somewhere else that these are in thousands. So this here says 3 million, but it's really 3 billion in taxes. I'm pretty sure you can double check that. GDP is in millions, so it's not 34,000, it's 34 billion. Median household income is that's the number as it is, so it's 63,000 is the median household income. Population is the number itself, so it's 643,000. GDP per capita is the number itself, so it is 54,000 per person, living person in each of the state. Where's the state name? Oh, state name is here. There's also an additional index here. Okay, so all that looks good. You can get a whole data type for the whole data frame with this command, dtypes. And here, because we were working with taxes well, actually, first what we need to do is we want to normalize the taxes. Notice the total taxes is the total taxes, the total revenue from taxes. So obviously, states that have a much lower population will have a much lower state taxes. on average in general than states that have a much bigger population. However, we can get a tax per population, and then you get a more normalized measure that we can compare. So to do that is very simple. You just need to divide total taxes by population. Another way to do it would also be to divide total taxes per GDP. That's kind of interesting too. Like, how much are you getting taxed with all the money that is created in that economy? So we do that over here. Very simple to do that in Python as well. We just take the whole column, total taxes, / which is the division symbol, and divided by the whole column of GDP 2020 million. So this is taxes divided by GDP. Now it's going to get a little confusing when you interpret it because total taxes is in thousand and GDP is in millions. So you got to think about what the actual final number is, your taxes per GDP. And also we can create a taxes per population. That's also very simple, just like this one here. And I'll let you add the code here. And on the outcome, there's a taxes per GDP and taxes per population. So the taxes per population is 5.318. Now the tax per population is easier to interpret because I know taxes is in thousands, but population is in the actual numbers. So all I have to do to actually get the actual taxes per population is multiply by 1,000. And I actually decided to do that over here and also round the numbers because I don't need all these decimal points. Like we're talking about in the thousands and millions, like I don't need to talk about cents. So we can use the round function. I'm just doing the same thing as above, but we're doing round, open in parentheses, and also times 1,000. Oh, here I timed 1,000, the total taxes divided by GDP, but actually what I wanted to do is do that when we do the tax per population, not necessarily tax per GDP. Now, it actually may make sense to multiply taxes per GDP per 1,000 as well to get a more accurate measure, but I need to think about that as well. And also you can think about that as well. What would be a useful measure to represent this? It's going to be some kind of thousands or hundreds or million here in taxes per GDP. Taxes per population, I think we just multiply by 1,000 would be more straightforward. And here it's done. I did it for both, but once again, make sure you interpret this correctly. Tax per GDP. Tax per population means on average, every person is going to get taxed in the state $5,318.